Hello and welcome for our video today. Today we are going to be talking about lighting, or I'm going to be teaching you how to write ionic equations. I've done other videos on this topic here. Now you should know that before you write an ionic equation, I expect that you know how to write balanced chemical equations. Okay, so if you have a problem in that, then you're supposed to check on our previous video, and then you'll be able to understand how we balance chemical equation. We have some videos there which are very straightforward and very simple to understand. Now, for you to be able to write an ionic equation from a balanced molecular equation, you are supposed to understand the concepts of solubility of salts. Now, for you to be able to understand those salts that are soluble and non-soluble salts, you require to understand this table here. This is called the solubility table or solubility rules here. It will show you which salts are soluble and which are not soluble. Now, that one will be very important as far as you are writing chemical equations, ionic equations. Now, we have an equation here. And this equation is between zinc metal. A zinc metal is a solid. Now, the symbol of that zinc there will be solid. We have dilute sulfuric acid. This is dilute sulfuric acid. Now, the symbol for that one is aqueous, meaning that it is soluble in water. Okay? All sulfates are soluble apart from calcium sulfate, lead sulfate, barium sulfate, and silver sulfate. So all these others are soluble. So here we also have a zinc sulfate, which is soluble. So sulfates of zinc are soluble. So the state of that compound will be aqueous. Then we have our hydrogen gas. This is a molecular compound, so it's a gas. It's not an ionic compound. Now, the next step is now, after we have identified the symbols for this equation, and this equation here is balanced, we are going to replace now this aqueous, this soluble salts, with what we call their original ions. For instance, this is what we call sulfuric acid. It was originally made from two ions of hydrogen aqueous. You can see we have a H2 there, and then one sulfate like this. This is it. One sulfate. We put a plus here. One sulfate ion. Then you put an aqueous. Don't forget to put that symbol. So this here actually represent this one, but we have stated now into individual ions that made that compound. Let us look at our zinc here. Zinc sulfate was originally made from a zinc ion like this. So we are going to remove that one and replace it with a zinc ion. We put aqueous there, plus a sulfate ion, that one there. Then we are going to put an aqueous there like that, and then we have our hydrogen gas like that. So now you can see that we have been able to write that one in form of ions wherever it is possible. For solids, we don't have any ions, so we are going to it's going to remain as a solid. For gases, it's going to remain as a gas. But for this other, we are going to return now from the previous ions that formed these substances here, or this ionic compound here. Now, after doing that, we are going to look at the reactant side and the product side, and then we identify those ions that are similar. We remove that one. Sulfate is similar because we also have a sulfate here. You see? You can remove that sign there. Then you put your there, hydrogen there. Then you can also remove this one here. So let us take this back like that. Now, you see? So, zinc is a solid on that side, zinc is an aqueous on this side, so you cannot be able to remove. They are not similar. You have two hydrogen ions here, and you have two atoms of a molecule of hydrogen gas there. Now, in this case, there is nothing else that you can move. Now, what you have here, we have sulfate ions. So, in this equation, these sulfates ion here, or the ions that we remove which are not taking part, actively taking part in a chemical equation, are usually called spectator ions. Or these ions, other ions that were taking part in a chemical, in this chemical reaction, are usually called the ions that are actively participating. Now, that is our complete or net ionic equation from the original molecular equation that we had. Thank you very much for watching this video. I hope now you get what we say when we talk about ionic equations, and keep watching our videos. You learn more on this as we move on. Remember to subscribe, and we meet in the next video.